Hello friends, welcome to another video. In today's video, we are going to look at the practical use case of DAX function called natural inner join. I just did a video to talk about how natural inner join DAX function works. I will post the link of that video in the description of this video on my YouTube channel. Uh, Actually, I never used this function in the past, and this was the question posted on Microsoft Power BI community forum where I end up using this function. I'm pretty sure there are many other ways to solve it. Actually, end of this video, there is a question for you guys to come out with a solution without using natural inner join. I know there is another way to do it, but let me know in the comments what you think is the other way to do that. And one more thing, don't forget to subscribe the channel and hit the bell icon button so that you get notified when the new video comes out. Let's get to the detail of the question posted by the user and then go from there. Here on the Power BI community forum, the question was very simple: problem mixing several tables to obtain one result. And well explained problem. Thanks to the user who posted this. Basically, the question is, and I'm pretty sure this is pretty common scenario. Table A, which has a year, car, and quantity. So basically, car is sold, two quantity of car A sold in 2021. So that's pretty much what this table is. And the table B is tells you what parts get used in each car. So car A, for example, has two parts, part 1 and part 2, and the quantity get used is like kind of an assembly. So one car has multiple parts, and those parts are how much quantity of each part get used into that particular car. Again, one thing you have to pay attention here, the part can be used in the multiple cars as well, because if you look at the part 1 is used in car A, 5 pieces. The same part is used in car B for 7 pieces. So it means part can be used in the multiple cars. So good, another very good table. And the third table, and which is talks about how much each part cost per year, right? So part 1 in 2021 was for $1 or whatever the price is. And in 2022, it is for $4. And now these tables are really well defined and well structured from the data perspective. So what is the end goal? End goal is to find out what is the total price or the total cost of each car sold by year. So basically, what we need to do is to solve this. First, we need to look at the car 2021, 2 pieces sold, and then what are the part used? So 1 and 2 part is used, so it means 10 pieces of part 1 used, and 14 multiplied by 2 quantity of the car, so it's 28 pieces of that. So it means that many pieces units are used, or the parts used in those 2 cars. And then we need to find out the price of each part by year and multiply it with the number of pieces used, and then find out the total price. So that's basically is the end goal. So in year 2021, which car sold and how much quantity, that is coming from table A, that's already there. And then we have a unit price, like how much it is costing based on the part. So we have to find out the price of the parts based on the year from the table C, and then we multiplying the total price with the quantity sold, $94. So that's kind of what the end result is. So what we're going to do here is first I'm going to take this tables in Power BI, and then we are gonna the most important part is unfortunately we cannot use these tables directly, and we will improve the data model based on these particular tables, and then we will structure, always the goal is to create a star schema, and then we create that, and then we will see how this we can get the end result, which is getting the unit price and the total price. Let's look at the data model. First and foremost thing I did to create a data model, I created the dimension tables, right? Because all these are transactional or fact tables, you can say. We have a car sold, and that's again a fact table, which is table A. and then we have a parts used in the car. It's kind of a bridge table in a way. And then we also have a price table, which is telling us, how much each part cost per year. So what I did is I created a cars table, which is just a unique value of cars, and that's a dimension table, which is connected to the table A. Table A is again cars sold, and then also connected to table B, that is which parts get used in the cars and how much. So now this dimension table is created used with table A and table B. And parts table, I created another dimension, which is just a simple parts table. It is connected to table B, which is like which parts get used in the car, and then also get used with the table C. And table C is where we have a per year a sale of price of each part. So this part dimension is now connected to table B and table C. And again, because it's a one-to-many relationship, because parts and cars are on the one side and that these transaction table are on the many side. And then of course, when you're working with dates as in a best practice, you always want to have a calendar dimension in your model, because that's where you will perform all your time intelligence calculation. And in this particular case, we have a time factor in this calculation because there is a year involved, which tells how much each part cost per year. So calendar dimension, again, it is connected to table A and also connected to table C. So table A is how many cars sold per year, and table C is price of parts per year. If we look into the raw data, again, this data I copied it from my from the forum. So table A, again, year, car, quantity, and I created a date table because I just took the year and created at the last date of the year. Assuming this is sample data, you might have the car sold on different dates. So to create the relationship with the calendar dimension, again, I'm pointing these things out, like how you should be creating the models when you have only year column and you don't have a date column, that you can create a date, a dummy date, and then you can connect to the calendar table. So I created December 31st. So that's is to create a relationship with calendar table. So table B is just a part table. Again, there's no calendar factor in this, so which car has which part used and how much. And the table C is again each part has the price. Again, I create the date column here and just to get the price of that particular to create a relationship with the calendar table. Now once this is done, so again I create three-dimension tables, cars, which is just A and B. It's a unique value, and again parts, unique value 1 2 3. You might have a dimension has multiple other columns on which you can slice and dice the data, but in this particular example that is not relevant. It's more about how you model it and how we will use the natural inner join DAX function to get the result what we're looking for. And then we have a calendar dimension, our standard calendar, just the date and the year column, right? That's pretty much what I did. So now the question is, like, how are we gonna work with this? And if we go back, the ask here is to look at the car, get each part of that car. So basically from table A to we need to go to table B, and from table B so we gotta get the year from the table A when that car was sold, and then we need to look at the table C to get the price of each part for the year the car was sold. So basically table A need to get the data from table B, which is the part and the quantity, and then also we need to get the data from table C. So what we need from the table C is the year we need to get from the table A, and part we need to get from the table B, so that we can get the price. Now there is, if you look at the model, why I'm bringing that up is if you look at the model, we don't have any direct relationship between table A, table B and table C, right? There is no way, and all these relationships are one to many direction and the dimensions going. So if I filter on a car, that doesn't mean it filters on the part table B, because the relationship is one to many. Yes, I can have the cross filter relationship to do it a both direction, but that's not what I'm going to do, and that's never been recommended best practices as well. So this is what we have. So now where natural inner join function come in the picture, let me actually get to that, and then we will see that particular function in action. Let's look into the measure which I created to get the result what we're looking for. What I have on this page is I created a table visual to visualize how this will work. So here it is coming from our calendar table, because again we need to get the, when we're visualizing the data, we are going to get it columns from the dimension table. So I'm not using the year from the cars table or the from other tables, but from the dimension table. So here I'm getting from my calendar table. Car I'm getting from my dimension table, which is cars, right? That's what it is. And then the car sold, and that is just a sum of table A, the quantity. So what does this means is we're saying, okay, in 2021 a car is sold 2. That's what we get the result using a dimension table. Now next question in here is to find the unit price. Unit price is again see what parts are used for each car, and then for those part in the year that car has been sold, what is the price. So that's kind of is your unit price. Again, going back to the model, we need to get parts from here from table B, and we need to get the price from table C, and our sold quantity is in table A, and table A does not have a direct relationship. Again, I'm coming back to it again and again. Table A does not have a relationship with table B, and it does not have any relationship with table C, right? So that's the one thing you want to keep in mind. So what we're going to do is we're going to first we need the unit price, right? So I'm going to start writing a measure, and we will build it step by step. I already have done the measure and I know how it's going to work, so I'm going to try to explain while doing the measure. So let's call it unit price, maybe parts unit price, right? That's what it is. First we need to get the parts used on each car, right? Because that's what is the first part, is like what parts are used for each car. So when I'm at the row, the first row, I need to get the parts of car A. Store it in a variable called cars sold. So what we need here is summarize. So what we need is we need to get the car sold by each year. So which is in a table A, that's what is car sold. And then calendar, we will get the date from calendar table. Again, the reason why we want the calendar date is even we are looking at the year level because the relationship is on the date level. Think about if this was a transactional data and there was data by date and we want to sum it by quarter or month. Then the lowest granularity is the date, right? And that's what the relationship is. So we're saying is summarize table A on calendar date and on car. Again, we are using the dimension table, right? That's what we need here. And what this will give us, it will give us what cars has been sold in what year, right? So this is just a simple table. And now we need the parts, car parts, right? For each, again, this doesn't have a concept of the year. It is only by car, how much each quantity is getting used. So what we're going to use is, so I'm going to go and again summarize, store it in a table, our table B, which is our parts. And then what we're going to do is, again, that we're going to get from the same dimension table cars car, and then we're going to get from the parts part, and we're going to say what quantity is being used, right? So table B quantity. So what does this means is, now it will give us when I'm at the row A and at the first row, it is going to give me, because we are using the common dimension table, it's going to look at the car A and then it's going to go to the parts table. It's going to say, okay, from part, for that car, how much quantity is being used. So now at each row level, if we look into this particular table, if a car has 2 parts, it will give us the 2 rows of that car or the parts of that car and with the quantity. So that's what it is. This does not have any, because again this is coming from table B and this is coming from table A, but there is no relationship between these two tables. Remember we saw that in relationship diagram, there is no relationship, but now we have a common a column in these two tables. If you look at the cars.car is coming from cars table, which is a dimension table, and also in this particular car sold, the car column is coming from dimension table. So now I can do the natural inner join on these two tables and create a table. Again, do check out first video, the link is in the description of this video, what the natural inner join is. So the goal here is, what we want to do is we want to, okay, each car, part of that car, how much quantity for each part is used, and when that car is sold. So basically we bring the date element into this table. So what we're going to do is we're going to say let's call it cars with cars sold with parts, right? So now I can use natural inner join between table cars sold and cars part, cars sold and cars parts. Okay, what does this means is I will get a 4 columns in this one. I will get the car column, I will get the part used for the car, I will get the quantity, and from this table I will get the date. And if you look at a natural inner join function, it join on the common column, and in this case is the car, and then give the column from both the tables, all the column from both the tables. So we now get a table in cars sold with parts, the date element of that as well, right? Date and part and the quantity. Now to get the price for the year, we will do another so-called natural inner join. First we need to store it in a variable, again similarly what we did in the parts price. So each part, what is the summarize, okay, summarize, we're gonna go table C. So now what is it in the table C? We need each part. Again, we're going to get calendar date and what is the price, right? That's what we needed. So again, we are using a dimension table, so we are going to get into, okay, table C, each part on calendar date, again that's coming from the dimension table, what is the price? So this will give us the price of the each part by date, right? So we get that here. Now what we need is let's call it cars sold with parts price, right? So now we do the natural inner join. Let me write this statement and then I will explain what's happening here. So first we're going to use the cars sold with parts, and other one is parts price. So we're doing natural inner join. So now we're doing natural inner join between cars sold with parts. So we know each car, what parts are used, how much is the quantity, and when that car was sold, because we have the date from the calendar dimension. And the parts price is telling us, okay, this part on this particular date or year, in this particular case, this is the price. And when we're doing the natural inner join between these two tables, row number 6 and row number 8, so what we have is we are going to get one single flat table, and what in that table is going to be, there's going to be car, part, quantity, date when it is sold, and then the price at which it is being sold, right? The common column between these two will just stay, because what are the common columns in these two tables is going to be parts part and the calendar date. if you look at that, is because they are coming from the dimension table, and that's why we created the dimension table, so that we can connect this together, natural inner join. Again, go back, check my first video, that's very, very important. So now what we have is, this is pretty straightforward. Now we got the table with a row flattened out, data came from table A, B, C. Now we can simply run a sum x statement on this one. So what we're going to do is sum x, our car sold with parts price, and we have the price in this, and then also we have a quantity in this. Again, this is the quantity of the parts, and this is the price of each part for the year when the car was sold. Okay, so let's bring this measure into the matrix view in the table view here and see what numbers we get. And I will explain what these numbers are. So we're getting 47, 25, that's a unit price, and 90 and 109. So I created an Excel sheet to explain how we get to these numbers, to make sure that you understand this. Okay, let me bring my Excel sheet here just to explain the calculation. So again, this is the car sold per year, this is the parts of each car, and this is the price. Again, same data model. So how I broken down, so let's say in 2021 car A is sold, 2 pieces of car A was sold. What parts are used for car A? It's a 1 and 2, so these 2. And how much quantity? 5 and 14. So this is the parts used. And what is the price for each part for the year 2021? If you look at the part 1 in 2021 is for $1 and part 2 is $3. So that's what is the price for each part for that particular year. And now 5 multiplied with 1 parts quantity multiplied with price $5, and this is 14 multiplied with 3, $42. And the total unit price for car A for the year 2021 is $47. And similarly, I did it for car B. So this is $47. This turned out to be $25 based on the quantity used in each car and the year the car was sold. And that's exactly the number we are getting, $47 and $25 and so forth, so on. So that now we know how much each car has for the year, what parts in each car has been used and how much that part is used. So that's the first answer for the question the user posted. Now the second is pretty straightforward, is just to get the total price. So what is the total price? So we sold 2 cars and the unit price is 47. So the total will be this is for each car, right? For one car it's a $47, it's a 1 car $25. So multiplied total cars sold with the unit price will give us the total parts price. So that's pretty straightforward. How we're going to do that? Let's write a measure. That will be total unit price. So let's store in a variable. Again, I love storing data in a variable so that I can debug it if needed. And let's say cars total price. So what that is, so first we need summarize. So because we are looking at table A. Table A is, why we're using table A here? Because that's where the actual car sold data is, and that's the base data which connected to the parts and also the price. And then again, what we're going to do is, because we are visualizing the data by calendar, date, and by car. Again, we keep in mind we're using the dimension table columns, and this is very, very important. And we are summarizing on this one, and then add columns. We are adding a columns onto our, because summarize will return a table. Again, what this summarize will return, when I'm at the row, first row, it will return 1 row of 2021 year, 2020 date of last date of the year, and then cars, that's the ABC or whatever the car is. So it will return 1 table with that 1 row, and then we're going to add columns. So what we're going to add is to cars sold. How many cars are sold? It's a measure, so that is the cars sold. And then what we're going to have is unit price. Now that's also a measure which we just did, parts unit price. Actually, let's call it parts unit price. Now we have 2 measures to do our final calculation. So this will give us each car how much it is sold on a year, whatever the year we're looking at, and what was the unit price, parts unit price for that particular year for that car. And then now we can simply run a sum max on this cars with total price, which will be cars sold multiply with parts unit price. Let's visualize this and see what we get. Here you go. So we get 2 cars sold, 47 total cost, and 94, 75 this, and 695. And let's quickly go back to the community forum and the result what user is looking for. So if you look at that, $47, 25 is the unit price, 91.08, and this is the total price. That's exactly what we are getting here, and I think there is a little discrepancy in here, and the reason is because I think he did a manual calculation and there was a mistake in the calculation. What are the learning from this video? Actually, I really enjoyed doing this, and as I said at the start of the video, I never use natural inner join function. I could have done another ways as well, but this is what triggered me to use natural inner join. Again, the step was first we made sure that our data model is in the right shape, right? We created a cars dimension, parts dimension, and a calendar dimension, set the relationship, and then from there we use natural inner join. The reason why we were able to use natural inner join because in our summarized table we were getting the columns from our dimension table, which were common between table A, B, and C, and then we need a common columns with the same lineage in the natural inner join. Again, I'm repeating it this probably the 4th, 5th time. Do check out the first video, that is around 7-8 minutes video, which talks about the basics of the natural inner join. And I love this video. Let me know what you guys think about that. Again, at the start of the video, I mentioned there are other ways to solve it. Let me know how you would have solved this, or what you think is another approach you can take it to solve it. The purpose of again this video was to walk through the natural inner join function, that how it can be very, very helpful. I hope you enjoyed this video and learned few things out of it. Let me know what you guys think, and make sure to hit the subscribe button and bell icon to get notified for the upcoming videos. Until next video, have a great day. It's always a pleasure to do some interesting videos. Thank you very much for watching. Bye for now. Have a good day. Cheers.